Two spheres have the same positive charge. A point M is midway between the two spheres. Along the line joining the spheres, what is true about the electrical field and the electrical potential at M? And you can see options: electric field 0 or maximum, and electric potential minimum positive or maximum positive value. So what about electric field? We know that electric field multiplied by charge gives us force acting on a charge at some point. But without any calculations, you may deduce that if you put any charge, plus or minus, it doesn't matter, at M, and since distances are the same and the charges are also the same, or I mean of magnitude, there will be same attraction or repelling due to each sphere, and hence net force will be zero, and hence electric field at M also will be zero. Or we know that electric field vector is it has direction from plus to minus, so this charge produces field from plus, so in this direction, and of magnitude k charge, let it be q, divided by some distance, let it be r, and field produced by this charge, it's also positive, so it will be from plus in this direction, and of magnitude same charge, same distance, so there are two vectors which are in opposite directions but of the same magnitude, so they cancel each other, so the resultant electric field vector is zero, so field is zero at M. What about potential? Potential formula is k q over r, where r is distance from a charge, q is charge, and you should take into account sign of a charge, so potential may be plus or minus, it depends on it is produced by positive charge or negative, but electrical potential is scalar, not vector quantity, and the resultant potential is just the sum of potentials, and but each potential may be plus or minus due to the sign of charge. And you may meet such a graph. It's the resultant potential between two charges. It looks like this. How it arises? You know that since potential is inversely proportional to distance from a charge, so potential produces by this charge, it looks like this. It decreases with distance from this charge, and also potential produced by this charge is also inversely proportional to the distance from this charge, and decreases. And since potential is scalar, the resultant potential is the sum, so we just consider the sum of these two functions, and it looks like this, something like this. So it's at M there will be minimum value of potential. And also you know that electric field is, it is given in a data booklet, that it's negative delta V over delta R, but this delta actually means derivative. And if you know that a function, if it's potential has minimum at some point, derivative, and what is derivative? It's gradient of a tangent. You can see that there is horizontal tangent, and you can conclude that field is zero at this point, because field is gradient of a tangent of potential of the graph of the potential. So potential has minimum at M. Or if you don't know such a graph, you may deduce that since it is given that it's minimum, positive, or maximum, it's about what? Extreme values. Maximum or positive, it's about extreme value. And uh, for example, let this distance be 1 charge also 1, so you may do the next. Potential produced by this charge, it's what? K Q over R, and Q, let Q also be 1, so you can see that it will be 1 at M, and potential produced by this charge, it's also will be 1, so 1 plus 1, it's 2. And then just check another point, let it be point 0.5, not 0.5 because total distance is 2, let it be 0.5 and 1.5, 0.5 and 1.5, so it becomes 1 times 1 over 0.5, which is what? 2, and for potential produced by this charge at this point, it becomes what? 1 times 1 divided by 1.5, 1.5, and it's something, but it's positive, less uh, greater than 0, some positive value. But since potential is scalar quantity, the resultant potential is the sum of individual potential. So at this point, it will be 2 plus something. I don't want to calculate it, it doesn't matter, but it means that it will be greater than 2. And since at M is 2, at another point it's greater than 2, it means that at M it's minimum. If you calculate at this point to be less than 2, it implies that at M is maximum, provided that at M is some extreme value, minimum or maximum. And that's all for this question. So A is correct. So that's all for this question.